Now we go on to study the equation of a plane passing through a point, that means a given point, and parallel to two non-parallel non-zero vectors. Right. So let us consider the given point to have the position vector as a bar, and the two non-parallel non-zero vectors we called as b bar and c bar. So let's visualize how the plane would really look like and how it will be situated with reference to these two vectors b bar and c bar. Okay. So in the most general form it would be something like this. Okay. Suppose we have some plane containing one vector, say c bar. Okay. On top we may have another parallel plane, okay, containing some other vector, say b bar, the other vector, right? And our required plane might be yet another parallel plane passing through the given point a bar, okay, the position vector a bar. So this is the most general possibility that we want to find out the equation of this particular plane, right? Now to find this, if you observe, as we have seen earlier, we have to get hold of some vector which is in the normal direction to the plane. That means it is perpendicular to the plane. Alright. Now let's ask the question, can we find out such a vector? If we look at the figure, see we have b bar and c bar as non-parallel and non-zero vectors. Now if you recollect from the basics of the vectors topic, we know that the cross product of the two vectors b bar and c bar will be in a direction which is perpendicular to both of b bar and c bar, right? And we find that direction by using the right hand thumb rule. So clearly b bar cross c bar is the vector which is definitely perpendicular to the given plane. Alright, so we have found out one vector which is b cross c. Alright, now with that we consider a generic point P as usual with position vector r bar. Alright, then we join the given point A with P so that we get the vector AP bar, and since AP bar is clearly perpendicular to the vector B bar cross C bar, we write their dot product, that is AP bar dot B cross C must be equal to 0, isn't it? So solving further, AP bar is R bar minus A bar dot B cross C is equal to 0. On further simplifying, we get R bar dot B cross C must be equal to, taking the other negative term on the right side, we must have A bar dot B cross C. And from the vectors we know that both of the sides represent the scalar triple products, so we can also denote that in the box, that is box product of RBC must be equal to the box product of A, B and C. And we know that the box product is nothing but the determinant of all the coefficients of the three vectors. Alright, so this is the equation of the plane, which is passing through a given point and parallel to two non-parallel non-zero vectors. Now if you consider the third step, that is a more conceptual, that is that you can visually remember, that is R bar minus A bar is a vector in the plane and B bar cross C bar is the normal vector. So clearly their dot product has to be 0. Right. Now there is another way of looking at this, and that is called as the parametric form. And we can write the parametric form as R bar is equal to A bar plus lambda B bar plus mu C bar, where lambda and mu are called as the parameters. Now once again let us see from where it comes. Okay. Let us consider this is point A, then this is point P, that is R bar. So therefore if you consider the vector AP, that is nothing but R bar minus A bar. Now if you see, we had talked about the two vectors B bar and C bar, okay, which need not be actually residing in the given plane, but since in mathematics we deal with the free vectors, we can move them up, alright, and bring them in the plane. Okay, so suppose I take a kind of projection of C bar in the required plane, so I can always find its counterpart in the given plane. Okay, so therefore that is the required counterpart of C cap in the given plane. Similarly, we can take a projection of B bar and we can also find out its counterpart in the given plane. Okay, so this is where the B bar sits. Okay, so here we have B bar. So now you see that clearly the three vectors R bar minus A bar, B bar and C bar, they all lie in the same plane, that is they are coplanar. And if that is the case, then one vector can be written as the linear combination of the remaining two. Okay, so therefore we can write R bar minus A bar is equal to lambda times B bar plus mu times C bar. Okay, and from that only we get the parametric form of equation of the plane. Alright, now let us go ahead and solve one example based on this. Find the vector equation of the plane passing through the point 4, -1, 0 and parallel to vectors I minus 3j plus k and 2i plus j minus k. Okay, so let us call the given point as A bar, then first vector as B bar and the second vector as C bar, to which the plane is parallel. Okay, now first of all let us calculate B cross C, because that's what we are going to need. So let us keep that ready. So here we have B cross C to be equal to I, j, k. Coefficients of B are 1, -3, 1, and for C they are 2, 1, -1. So this is clearly equal to 3 minus 1, that is 2i, minus -1 minus 2 is -3, so that becomes plus 3j, and lastly we have 1 plus 6, that is 7k cap. Okay, so here we get B cross C. Now we have to also calculate A bar dot B cross C, which is the right side. So that is where we calculate once again the determinant, and the first row is to be replaced with the coefficients of A, that is 4, -1 and 0, and remaining rows remaining the same. Okay, so therefore here we have 4 into bracket 2. Now minus becomes plus. Okay, now here we get -1 minus 2, that is -3, and lastly 0. So we have 8 minus 3, that is 5. So the right side turns out to be 5. Okay, now if we recollect the way we write the equation, that is R dot B cross C is equal to A bar dot B cross C. So therefore we have R bar dot B cross C we have already calculated, so that is 2i plus 3j plus 7k is equal to, the right side also we have already calculated, and that is nothing but 5. So this is what is the vector form of the equation of the given plane. If we want Cartesian form, we can write it directly. Since we have 2i, it is 2x plus 3y plus 7z and bring 5 on the left, so that becomes -5 equal to 0. That's it. So that's the Cartesian equation of the same plane.